Welcome, Algebra 2. Let's take a look at Chapter 3, Section 3, solving quadratic equations using square roots and completing the square. To begin with, I'd like you to partner up with somebody and spend a few minutes working through the Desmos module called Completing the Square. As always, if you're going to work with someone, then put both your names in. I only want you to spend about 10 minutes, so hit pause on your video, come back in 10 minutes. All right, welcome back. Chapter 3, Section 3, completing the square. If we were to have a polynomial like x squared plus 8x, what we could do is we could graphically draw that as a square that is x times x. And then this height being x would mean we would have 8 rectangles with the height of x, but a width of only 1 unit. So this would be 1x, this would be another 1x, 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 and you would have 8 x's. If I try to put these things together, no matter how hard I try, there's no way to take this shape here and this shape here and create a perfect square. If I put them together, that's just a bigger rectangle. If I put it here, that doesn't work. No matter how hard I try, it doesn't work. But what I could do is take one of these, put it down here. Nope, still not a perfect square. Maybe if I rotate it. Okay, we're getting closer, but we're missing quite a bit here. How much are we missing? Well, let's find out. Let's take half of the 8, which left us 4 and 4, so half of 8 is 4. And then if we take 4 and square it, 4 squared is, 4 times 4 is 16. So that means what we need are 16 little squares to complete the square and make a perfect square. If I were to draw in 1, 2, 3, 4. We could see that we've got 4, 4, 4, 4, which would make 16 little squares. Now we have a perfect square. Well, it's no longer x, it's now x plus 1, 2, 3, 4 units, because each of these were 1 unit. So this side becomes x plus 4. From here to here, it's x plus 1, 2, 3, 4. So if we were to take our polynomial and add 16 on there, that means we would get x plus 4 times x plus 4. That would give us our area of our square. You take a side and you square it. This side times that side. Well, a side square. There we go. We just completed the square. So, how do we complete the square, right? That's what our goal is today. Completing the square. We have x squared plus bx. B is some kind of a number. It works best if it's a number that we can easily take half of. So even numbers work really, really well for this. Half of b, well, that would be b divided by 2. And then if we were to square it, b divided by 2 squared would give us b squared over 2 squared would be 4. So what we're adding to the end would be our b squared over 4. And then this factors into something squared. Something squared. Well, what did we square? We squared b over 2. looks kind of tough, right? It's easier with numbers. I understand that when we have all these letters, variables up here, it gets challenging. But that's the process that we're having. We're finding how many little squares do we need to add on. And the way we get that is we take half of the middle term and then we square it. That's the number that we're going to add on. Those are the tiny little squares that are missing. So, how about you try? Half of that middle term, well, you could say half of 14. Half of 14 is 7. 7 squared, 7 times 7 is 49. So we're adding 49 little squares. And what we get is x minus, because this is minus, 7 squared. There's your 7 squared. So we take this number here and we square it. If we were to FOIL this out, x minus 7 times x minus 7 turns out to be this polynomial here that is a perfect square trinomial. Now some of you might be going, well, why didn't you take half of negative 14? Okay, well, let's find out what happens. Half of negative 14 is negative 7, and negative 7 squared is still 49. So you still get the same thing either way. Whether you look at it as negative 14 or positive 14, when you square something, you're going to get a positive back. Time for a brain break. The surgeon said, I have too many patients. Where do I begin? The nurse said, follow the order of operations. Please excuse my dear Aunt Sally, parentheses, exponents, right? Multiplication, division, addition, subtraction, PEMDAS. How does a ghost solve a quadratic equation? Ooh, Halloween is coming up. How does a ghost solve a quadratic equation? By completing the scare. That was a good one. I like that. Well, one of the reasons that we complete the square is we can use it to help solve a quadratic equation. Something in the form of ax squared plus bx plus c equals 0. And it does need to equal 0. If it's not, we put everything on the same side until it equals 0. As long as our a value is an invisible 1, completing a square is not too bad. As soon as we put a number out front, other than 1 though, completing a square gets a little more challenging. So let's take a look at one where we have 1x squared minus 18x plus 52. Our goal is to be able to solve it. I'm going to put the 52 on the other side. And the reason I do that is now I can complete the square with what's on the left-hand side. 18x, right? 18x is our so-called middle term, the thing that we're going to take half of. So what is half of 18? It is 9. You can always divide by 2. If I give you a number and you're not sure, 18 divided by 2 is 9. That's how you take half. Now we take our 9 and we square it. 9 squared is 81. So that means to make this a perfect square trinomial, I have to add 81. Well, if I add 81 to the left side, I also have to add 81 to the other side. All right, what do we do next? Well, the left side is a perfect square trinomial. So this part here turns into x minus, because that's minus, and then we had 9 squared. 9 squared. On the right, put in your calculator, negative 52 plus 81. I get 29. No, you cannot add 9 to each side right now, and the reason being, it's x minus 9 squared. It's not just x minus 9. We need to eliminate that square. How do we eliminate a square? with a square root. And we saw before, when you take the square root of a number, you're going to get a positive and a negative answer. So on the left, the square root of x minus 9 squared. On the right, positive or negative square root of 29. Are we done yet? No, we have not found x yet. But we're getting closer. When you take the square root of a square, that's the easy part. The square root and the square cancel each other out. We get x minus 9 equals positive or negative square root of 29. Is 29 a perfect square? 4, 9, 16, 25, 36, 4. No, it's not. And 29 can't be broken down. So the only thing I can do is I could add 9, and x will equal 9 plus or minus the square root of 29. 9 plus the square root of 29, 9 minus the square root of 29. And you might be thinking, well, I don't know what that means. That's okay. Those are the exact answers. If we would use our calculator, we could get an estimate. So let me break out the calculator. We'll take a look and see approximately what is it. Well, it's 9 plus the square root of 29. So it's about 14.4. And it's 9 minus the square root of 29, which is about 3.6. If you need an estimate, there you go. If you want exact answers, 9 plus, 9 minus the square root of 29. I'm fine with exact answers. This is great. So what would you do if I gave you one that didn't have a 1 in front? It's got a 2x squared. Well, completing a square gets harder. It's also hard when the middle number isn't something easily divisible by 2, because then you get fractions. Speaking of being divisible by 2, divisible by 2, divisible by 2, divisible by 2. We could factor out or divide out a 2 from each of these. Up. I just said divide out, right? Divide everything by 2. Factor out that 2. Divide by 2, divide by 2, divide by 2. Because there's no x out front, we can safely ignore the 2. You can divide this side by 2. You divide that by 2. 2's here will cancel. And 0 divided by 2 is 0. Now we've got an equation that looks a little bit more manageable. What do? Well, we complete the square. Let's put that 30 to the other side. And let's complete the square. X squared minus 10x. We're going to add something here. And we're going to have our negative 30. And we're going to add something here. Question is, what are we going to add? Well, let's take half of that middle term, which is our 10x. Half of 10x. Half of 10. 10 divided by 2 is 5. Then we take our 5 and we square. So we would add 25 little squares. We're adding 25. We're adding 25. You add it to one side, you add it to the other side to keep it fair and balanced. Now we look at this piece here on the left. That is a perfect square trinomial. So we have x minus, because that's minus. And what number did we square? Well, we squared the 5. 5 squared. On the right, put in your calculator. Negative 30 plus 25 is negative 5. We're not done, right? And no, you cannot add 5 yet because this is x minus 5 squared. We have to eliminate the square. Eliminate it by taking the square root of the right, taking the positive, negative square root of each side, right? We square root the left, we square root the right. Why do we do it? Because the square root of something squared cancels out. So the square root of x minus 5 squared is simply x minus 5. And on the right, positive or negative square root of negative 5. So let me think about 5. 5 is not a perfect square like 4, 9, 16, and 25 are. So we can't really take the square root of 5. That'd be a decimal. We could, however, pull the negative out front. That negative gives you the I, and then we have square root of 5. How do we finish it? Well, we're looking for x. How about we add 5, add 5. Final answer, x equals 5 plus or minus I square root of 5. Can't really put that one in a calculator. All right, in the remaining time, you and your group work on Chapter 3, Section 3, completing a square. If you've not done so, please turn in your ACT prep. That was your homework. And don't forget to finish your quiz if you are not done with it. All right, bye guys. Have a great day.